Hello everyone, this is the tutorial for lab number 4, force stable vectors lab. In this lab, you are going to, just like the previous labs, you're going to find this file, which is this, and you're going to perform the experiment, which is very similar to what you will do in an in-person lab using this setup, right? You have a circular table like this, and you will be able to find angles for the equilibrium of different weights. Mind you, this lab has 3 sections, and you will get points based on what you do on each section. So don't panic if you find difficulties, especially with part 3. All right. I want to be doing office hours and helping you guys, but I know that for some of you, maybe this section will be a bit more time consuming. So I will try to go over this and explain what you need to do. There are a few things that you need to have clear, like some conversions and how to use the software. But once you do part 1 and part 2, it will be much easier to use the software for part 3. Okay, so try to do part 1 and part 2, and then you may want to go back and do part 3 later on. Okay, so don't leave this lab for the last minute because you may run out of time if you do that. Now, if you were in a lab setting, I will be assigning you different values, right? There's team numbers here, 1, 2, 3, 4, and 5. So you can just use 1, it's fine, all right? And those are your values you're gonna use for part 1, part 2, and then for part 3. All right. So for part 1, you have this table. The sketch, I will say you can move this because you can just take a picture for the sketch. You can just, you know what? Okay, so like that. All right, so you can use it like that. So 300 grams and 125 grams. So how do you find the force? I'm hoping that by now, when you're doing this lab, this is clear. But the force in newtons is mass in grams divided by 1,000 because you have to convert to kilograms, and then you multiply by the value of gravity. That's 2.94 newtons. The same with 125. You divide by 1,000 to convert to kilograms, and then you multiply by 9.8. That's 1.23 newtons. The angle is 120 degrees and 195 degrees. So that's very easy for part A and B. The equilibrium and the resultant. Now, the equilibrium is basically your resultant. The only difference is the angle. And you can find that using the software. So if you copy paste this in the browser, you're gonna find this. So you're gonna click here. Yep. And you're gonna put all the values at 0. And then let's start with what we have. So 300 grams at 120 degrees. So that's 300 grams at 120 degrees. You can always use the arrows to adjust the value there, 120 degrees. And then 125 grams. There. 195 degrees, that's here. There. Okay. So the resultant is there. That's the equilibrium force as well. So that's 3.47. That goes here. The angle the angle is not 140. That's the angle of the resultant. So what's the angle of the equilibrium? You are going to grab this and you are going to extend it. Oh. There. Until you see it's matching there. What angle do you see on the other side? 320 degrees. That's the equilibrium angle. All right. How do you find the weight of the equilibrium angle? You have to go from newtons to grams. So 3.47, that's in Newton. We divide that by 9.81. That's the mass in kilograms multiplied by 1,000. That's 353, 354. So we can write to 354 grams. This is what you will do in a lab. If you were doing the forces table in a lab, you will place a mass to make all the other masses in equilibrium. That's what we call it, the equilibrium. All right. Now, the theoretical value. How do you find your theoretical? And you know what? I mean, it's here, right? At least you know what should be. So let's do the math. Okay. So we have the force and the angle, right? I'm going to show you guys using the components. We're going to find the X and Y component for each. We're going to find the resultant, and then we're going to find the angle using trigonometry. All right. So you see, this is your F1. You can find F1Y, F1X, the same for F2, F2X, F2Y. So at 120 degrees, there. So for F1, F1X is 2.94 times cosine of one angle. So that would be the cosine of 120. You can just use that. It's fine. And F1Y will be 2.94 times cosine of, or sine, sorry, of 120. Now look what's gonna happen now. Cosine of 120 is negative. Why is it negative? Because that means it's pointing to the negative direction, to a negative X. You will see what we're gonna do when we wanna find the resultant. Now for F1Y, 2.55, that's positive because it's on the positive Y, negative X, that's fine. For F2 is 1.23 at 195. Cosine of 195. F2Y. So both are going to be negative because this is on negative X, on the negative Y. You're in the third quadrant. That makes sense. There. Right? If we use free sig fix, then with the Y component, that's negative. negative 0.32. Okay, so to find the resultant, let's focus on the resultant on X. You have negative, negative, so you're gonna add these two. That means that you have both forces on the negative X direction. So negative 1.19, negative 1.47, negative 2.66 newtons. That means on the negative X direction, by the way. And for the resultant on Y, you have one going up, one going down. So you have to subtract them. 2.23. That's on the positive Y direction. So that means that they are in the second quadrant. That's important because that's going to help you to realize the angle. Okay? So the resultant is the square root, the Pythagorean theorem, of the X component square plus the Y component square. So that will be the square root of 2.66 square plus 2.23 square. Now you're probably wondering why I don't put a negative, because the square will cancel a negative. It doesn't matter. The square will remove the negative on 2.66, so that doesn't matter. Now we can see. Square root of this. 3.47 newtons. That matches, well, yeah, 3.47, right? Perfect. Look at all the procedure. You're gonna do the same for part 2. What about the angle? Tangent of the angle theta, or tangent of the theta angle, right, is Ry over Rx. Now, Ry is 2.23. Rx is negative 2.66. So we need a negative there. So 2.23 over negative 2.66. Wait, 2.23 divided by 2.66. So that should be negative, negative 0.84. So we have to do the tangent inverse. About 40 degrees. Well, negative 40 degrees. And if you think about it, 360 minus 40, that's 320 degrees. All right. In the second quadrant, that will be 180 minus 40, 140 degrees, which matches almost there, right? So what do you write here? 3.47, perfect match. For this one, I will use 140 degrees. All right. And for the weight, times 1,000, 354. So, guys, that's how you do part 1. For the sketch, just take a picture of this. That's part 1. All right. Part 2, for part 2, you're going to use 300 grams and 400 grams at 90 degrees. So 300, oh, you don't have to put that in there. So you're just going to do the values. You can reset this. 300 grams, 400 grams. You want 300 grams at 0 degrees, 400 grams at 90 degrees. And that's your resultant. You have the resultant there, the angle there. So let's see what you need here. So the equilibrium is the resultant, as I said, 4.91. The resultant is 4.91. The angle of the resultant, 53.13. The equilibrium angle, that's about 227, right? You know how you can find this easily? You can do 180 plus 37. You can do 180 plus 37. It's the complement of this angle. But you can just use that. It doesn't matter. I'm not going to be very strict about that. 227 degrees for the equilibrium. Sorry, that's go here. All right, this is what matters, the resultant. And then the equilibrium weight is the same, right? We're going to just do 4.91 divided by 9.8 times 1,000. That's 501. So 501, 501. To find the resultant, the theoretical, the calculated, you're going to use the same procedure. All right. So for part 2, you want to start by doing F1x, F1y using 300 grams and 400 grams. Now, because you are at 0 degrees for 300 grams, F1y is 0. For F1x, remember, 300 grams is 2.94. 2.94 multiplied by, oh, that's it. Because that is a horizontal value. That's it. F2x is 0, but F2y is 400 grams in the 90 degree. 3.92 newtons. Okay, let's explain this why. Let's look at the graph, right? F1 is on the x-axis, F2 is on the y-axis. That's why there are no components. You don't have to worry about angles. They are making 90 degrees. To find the resultant is much easier. You just have to do the Pythagorean theorem between this value and this value. The square root of this square plus this square. That should give you this value. So that's very easy. And the angle is just like we did here. All right? There you are. Okay. What about part 3? Part 3, you have now 3 forces. And the thing is that I give you this table because you're going to find the x component and y component for each of the forces. And then you can do this. So I want to give you a head start for that. I'm going to use these values here. 57, okay, so $50, $170, and $160. So $50, $170, and $160. There. Now for 50, 75 degrees. For B is 120 degrees. And for C is 340 degrees. So you have your resultant, which is the equilibrium and the angle. So let's see what we can start filling up here. Equilibrium, resultant experimentals. The angle for the resultant is 60.82. The graphical, don't worry about this, guys. You are just gonna show me your graph, okay? So take a picture of this. The angle for the equilibrium. Well, 60 there, right? So it's gonna be about 240 here. 60, 30, 30. Yeah, around 240. 270 minus 30. It's around 240 degrees. That was here. Okay, so how do you do this? You need this to find the theoretical resultant. All right? So weight force. We need to do all the weight forces for all of these masses. 50, 170, and 160. So for 50 grams, what's the weight force? 50 divided by 1,000, multiplied by 9.8, 0.49. For 170, 1.67. And for C, 160, 1.57. Now, the angle. Use the angles I give you here. So 75, 120, and 160, right? So 75, 120, and 160. Oh, wait, 340, right? 340. All right. So how do you find the x component and y component? You're just going to use cosine and sine. So for A, 0.49 times, or that's the cosine of 75. So 75, I use the cosine of that, times 0.49, that's 0.13. That goes here. The y component will be positive as well. 0.47. You will do the same for this. Some of these will be negative because look at these angles. You're going to find the total of the x component, the total of the y component, and then you're going to use the Pythagorean theorem, just like we did in part 1 and part 2. I'm not going to do that because that's part of what you need to do, and then you can answer the questions based on those values. Okay? So make sure that you follow through with the instructions, and you should have no issues with this lab. It's all about using this and using your calculator and trigonometry properly. By the way, if you want to show me the calculations, you can always copy paste. For example, for part 1, you can show me all this. So part 1. There. All right. If you want to do it by hand, do it by hand. That's okay. Just make sure that it's clear so that when I grade this, it's actually clear and I can actually give you the proper feedback. Other than that, guys, I will be doing office hours like usual, or you can send me an email if you have any questions about this lab. Okay? So I'll see you guys on the next tutorial video. All right. Have a good one and see you later.